Hello children. Today we are going to solve IGCSE past year 2019 board paper, May-June. Paper code is 0625/21. This is paper 2, multiple choice and extended. Let us begin from the question number 1. Which quantity can be measured directly using a micrometer screw gauge? Micrometer screw gauge is used only to measure the diameter of small object or even to measure the thickness of a sheet of paper. Can't use for the area, mass of the sheet of paper and the volume of the sheet of paper cannot be measured. So we have option C. In question number 2, the velocity of an object increases from 30 meter per second to 50 meter per second in 5 seconds. And we need to calculate the average acceleration of the object. Average acceleration is given by the equation that is equal to change in velocity that I can write here v minus u divided by time. That is the time rate of change of velocity, final velocity minus initial velocity divided by time. Final velocity we have 50, initial velocity that the object was moving with 30 and the time period of 5. So 50 minus 30 is equal to 20 divided by 5. So that 20 divided by 5 that is equal to 4 meter per second square. Option number C. In question number 3, a heavy metal ball falls vertically downwards through air past 4 equally spaced levels J, K, L and M. This is level J, K, L and M. Time taken to fall from one level to the next are measured. It is recorded. What is the speed of the ball? Where is the speed of the ball is greatest and where is time shortest? Now, students, here you have to remember a ball is dropped from a certain height. As it moves downward, it accelerates and its velocity starts increasing and increasing. So when it is dropped, the initial velocity is 0. And when it starts moving, accelerating under the influence of gravity, its speed increases, accelerations increases. So as the speed is increasing, so here in the level L and M, where the speed will be fastest. And if the speed is highest in the level L and M, so the time taken by the ball to cross the level L and M will be short as compared to the time taken by the ball to cross the level J and K or even K and L. As the speed is highest L and M, in level L and M, time will be shortest. So we will go with the option D, that the speed is greatest between L and M and time is shortest between L and M also. Next question, question number 4. A body is moved from place X to place Y, where the gravitational field strength is different. What happens to its mass and to weights due to the move? Now, as per the statement here, children, they said a body is moved from some position X to some other position Y, where there is a difference in gravitational field strength. Gravity is different. So you can assume that the body is taken from the planet Earth to the planet Moon, okay, where the gravity is different on the surface of Moon. And we know that the mass is not going to change. So mass is not going to change. So it means option A and B you can eliminate first. They are wrong. What about the the same? In C and D, it is stay the same, and then weight is not. Weight is going to be changed as weight is equal to mass and equal to m into g, as the gravity is different on a different planet, so that the weight is going to change. So the best answer is here option C, stay the same and change. Question number 5. The diagram shows four solid blocks with their dimensions and masses. Which block has the greatest density? Now, for this children, I will do some calculation density by mass per unit volume. I have a mass 40. I which block has the greatest density? And so the object having highest mass and the least volume will be considered as the highest density. So I need to do some calculation. Density, mass of first object is 14 gram, and the volume of the first object is area into height. That the equation you can use, area into height, that is the volume. So 2 into 20, 2 into 10, that is 20. So you need to do the calculation here. 14 divided by 20. Let me use my calculator. And 14 divided by 20, that is equal to 0.7. So here the density for object A is equal to 0.7. That the unit you can write by yourself. And for the second object, we have the same equation, 48 divided by 20. And if I divide this 2 to the 4 to, and this is equal to 2.4. That is the density in gram per centimeter cube. And for the third case, C, mass is 54 and that area is 20. And if divide, so this will be 2.7 and the same unit, gram per centimeter cube. And the lastly in here, 68 divided by 50, and 2 3s are 6, 2 4s are 2 2s are 20 here. Then I can further divide. Even you can do this calculation direct in your calculator. In our GCSE calculator is allowed. 2 1s are 2 7s are this. So that is 1. So now you can compare which one is highest value. Here it is 0.7, here it is 2.4, here it is 2.7, and here it is 1.7. So 2.7 is greater, and option C is the right answer for question number 5. Question number 6. A student wishes to determine the spring constant of a spring where it obeys Hooke's law. Where it obeys Hooke's law, children. The table shows the result of the experiment. Weight is there, and what is the value of the spring constant of the spring? Spring constant of the spring is given by the equation K is equal to force per unit extension extension produced in a wire. When there was a weight 0, means no weight was hanged on the spring, the length of the spring is already 12 centimeter. Then there is a weight of 2 Newton, and due to that, the length of the spring becomes now 20 centimeter. But we need to find out what extension. So extension produced in this case is 20 minus 12, that is equal to 8 centimeter. So after finding the extension produced, put the value of force is 2 Newton divided by 8, and if you do the calculation, 1 by 4 is how much? If you do the calculation, 1 by 4 is 0.25. Let me do the calculator. 1 divided by 4, that is 0.25. So 0.25 I will get here. The same answer you will get if you take this value 4 when the force is 4 Newton. How much is the extension, children? Initial length was 12, and the total length when the total force is 4 Newton, this will be 28 minus 12, that is equal to 4 divided by 16, and divided by 16 by 4. Again, the same thing, 1 by 4, that is 0.25. And if you're thinking, sir, what about if I take the last value? In the last value, you can see that the extension is not proportional. Here, as per the question, it is given according to the Hooke's law, where it obeys. Hooke's law is obeying here up to 4 Newton force. When you differentiate to 38 minus 28, it is 10. The extension is more as compared to the weight. So that's why you can find the answer of question number 6 either by taking this value or this value. Question number 7. Question number 7 is here. The mass of 20 kilogram is held stationary by a rope and passing over a frictionless pulley. What is the tension T in the rope? This T you have to calculate. Tension in the string. Mass is attached. There is a mass, there is a force upward directions. So what is the total weight acting downward? Total weight, mass is there, m into g, that is the weight. So 20 into gravity, we can take 10, and that is equal to 200 Newton. What is this 200 Newton actually? 200 Newton is the weight acting downward. And as per the Newton's third law, action and reaction, 200 Newton is the force acting downward. That will be equal to the tension produced in a wire. So we will go with the option number D, seventh D. Question number 8. A boat starts moving across a river at velocity v perpendicular to the river bank. The boat encounters a current along the river of velocity u as shown in the diagram. Now, children, here you have to be very careful in this question. The river is a boat starts moving across a river at a velocity v. So this is the direction of boat. Boat is moving in the river like with the velocity v. The river current, the water river current is what is below like this. So think about the situations. The boat is coming this side and the water is there. So where you can find that the resultant direction or the resultant force acting on the boat, something with the influence of the water current. And I can predict, it's a general answer, I can predict that something that this boat will move along this direction. Instead of going straight, it will turn because the water current is exerting a force on the boat. So this something I'm getting answer like this. So where could I find this answer? If you are looking at option A, why option A is wrong? This is a wrong answer. U is there, V is there. The resultant force they are saying is that as per the option A, it means that the boat is going along this direction. It is not possible. As per the option B, they are saying that the boat will go in this direction. That is also wrong. In option C, I can see that I can put that the U is here, V is here, and two vectors acting in the two side of a triangle, then the third side will give the resultant opposite to the order of the other two vectors. Then R, I can see this resultant R is as per my prediction. So option C is the right answer. What is the problem with D? D is not the resultant here. You can see U here, V here, and the direction of the resultant we know as per the triangle's law in vector additions. R resultant should be opposite to the order of U and V. So the question number 8, children, right answer is C. Question number 9. In question number 9, we have a ball of mass of 0.50 kilogram and it hits the floor with some initial velocity and it rebounds at speed of 8. The collision between the ball and the floor remains for 0.50 seconds. What is the average force acting on the ball during the collision? Average force acting on the ball during the collision. So how will you find out? We have an equation to solve this question from the impulse question. As you know, let me use this color. As you know, impulse is given by children. Impulse is equal to average force multiplied by time equal to change in momentum delta. Delta P already know m v minus u like this. I can write. So I need to calculate the average force here. So I will use this part here. F average is given by mass v minus u by time. Now what is the mass? Mass of a ball is moving 0.50 kilograms multiplied by v the final velocity. After the collision, the ball is moving upward, opposite to the initial velocity. I can take its minus 8. Minus 8 that the direction of the ball has been changed. Minus u initial velocity, the ball is coming downward with a speed and divided by time, which time is given in the question, 0.5. So this part is cancelled out here and I can see here that the average force here, taking the magnitude, by taking the magnitude, this is 18 Newton. The direction of this force, ball hit on the surface and the question states that average force acting on the ball. So the ground will also exert a force. Ball is exerting a force on the ground in the downward direction. But the question is, what is the average force acting on the ball? So the average force acting on the ball by the floor will be in the upward direction. So our answer will be here 18 Newton upward. Question number 10. An object uh, an object falls from the top of a building that is 20-meter high. Air resistance is negligible. What is the speed of the object when it hits the ground? So by using the equations of motions, I can solve this question, and I have equation h is equal to v square by 2g from the equation of motion. And then height is given how much? 25 equal to v square divided by 2 into everything, which is 10. This v square is equal to 25 into 2 into 10. If you multiply 25 to the 50, 50 multiplied by 10 is 500. And then finally I need v. V is equal to square root of 500. So you can use calculator to find out this value. What is the square root of, let me clear this, 500. Square root is 22.36. The value I got in calculator, 22.36. Look at the options here. So we can go with the option B, that 22 meter per second is the velocity. A machine is very efficient. Very efficient machine means that it produces a large amount of, it uses very little energy, that output should be better. It wastes very little energy. If the wastage of energy is minimum, that is called the very efficient machine if the wastage is minimum. So question number 11, answer is C. Question number 12, a crane, a crane takes 2 minutes to lift a load to the top of a building. The change in gravitational potential energy of the load is 360 kilojoules. What is the useful power output of the crane? Power output, children. Output power is equal to useful work done, useful work done divided by per unit time. Useful work done. What is the useful work done? What is the work done? Work done in moving the object from one position to another position that is stored in the form of its gravitational potential energy. So work done is how much? This is given in the question 360 kilojoule divided by time is given 2 minutes convert into second, and this is second here now. You can do the calculation. 0 is cancelled by 0, 6 6 are 36, and then 2 3 are 6, and I got here 3 kilojoule per second. And what is joule per second? That is the unit of power. Power is given by W by T, and work is into joule, time into seconds, and joule divided by second is watt. So that you can write 3 kilowatt. So that's why here the answer is A. Question number 13. Question number 13 is here. In question number 13, the diagram shows a stone suspended on a string under the surface of a liquid. The stone experiences a pressure caused by the liquid. What would increase the pressure on the stone? We have a string, stone is attached, and it is allowing to lower into the water. If you recall that the pressure in water, underwater, is given by the equation H rho and G. H rho G. So density of water is same, G is same there, so both factors are constant. Here pressure is depending upon the height. Height means that under the water depth is increasing. If I lower the stone deeper into the liquid, so pressure will be higher. So the right answer is here. Question number 14. A stationary smoke particle is hit by the fast moving nitrogen molecules. Which row describes the motion of the smoke particle? and of the nitrogen molecule after the collision. So in question number 14, children, that if you say a smoke particle is at rest position, okay, a smoke particle, and it is collided by the nitrogen molecules. Okay. Nitrogen molecules collide. What happens with the smoke particles? Here the smoke particles come into the motion. That smoke particles will gain the energy of the nitrogen. It starts moving. But what happens with the nitrogen molecules is it rebounds back. And so question number 14 answer is A. Question number 15. Here you can see a night storage heater contains a large block of material that is heated electrically during the night. During the day, the block cools down, releasing thermal energy into the room and releasing the thermal energy into the room during the daytime. Which thermal capacity and which nighttime temperature increase will cause the most energy to be stored by the block? We have a large block of material that is heated electrically during the night time. It is heated during the night time, so it will absorb. So if it should be absorb more and more energy, its temperature will increase, releasing thermal energy into the room. And which thermal capacity and which night temperature increase will cause the most energy to be stored? So in this question, children, the thermal capacity of this unit, this heater should be very high. It should increase, absorb more and more heat so that it can release the heat during the daytime. And when it is absorbing the more and more heat, so then the night temperature will also increase. That will be a large. So question number 15 answer is A. Question number 16. 18 gram of water at 25 degrees Celsius is poured into an insulating cup. We have 100 gram of water, mass of water. I will write this is 100 gram. Initial temperature of water, TW, that is 25 degrees Celsius. We have the initial amount of ice, Mi, which is 50 gram, and the initial temperature of ice, that is theta, is 0 degrees Celsius. It is added into the water, and the water is stirred until the temperature of the water has fallen. The temperature of the water, this is the important point, and that means that final temperature of water is now 0 degrees Celsius. 18th gram of ice remains unmelted. 18th gram ice remains unmelted, means 32 gram ice has been melted. 32 gram ice converted into water. The specific heat capacity of water is given, and which value does this experiment give for the specific latent heat of fusion of ice? Fusion of ice you have to find out. Now in this question, children, what's happening? Ice is put into the water. So in that case, water will start what? Water temperature has fallen, so it means heat is lost by the water. Energy has been lost by the water, and the lost energy, the lost heat, is absorbed by the ice. Now that's why the ice starts melting here. And remember, ice is melting, phase changing is taking place. Now I can write a equation here. The heat lost by water is gained by the same amount by the ice, and that the sum of total heat is not, no part of the heat is going to the surrounding, so we can say that the entire heat gained by the lost by the water is absorbed by the ice, so there the sum of total energy is equal to 0. Now we have equation that the amount of heat given or lost by the object when there is a difference in temperature, and say that you can apply this equation for the amount of heat lost by the water. What is the mass of water? That is 100 gram multiplied by C, specific heat capacity 4 point, and into multiplied by delta T, difference in temperature. Final temperature of water is now 0. Initial temperature of water was 25 plus Qi, amount of heat, phase change is taking place, and for that I have an equation. Let's write what is the mass of ice that converted, that turned to the liquid? So this is 50 minus 15, that is equal to 32, and into multiplied by latent heat of fusion that we need to calculate, which is finally equal to 0. And student, when he do this calculation, so you will get that the answer latent heat of fusion is something about 3 to 8, something about 328. And as per the options, we will go that this is nearly equal to 330 joule per joule per gram. So that is the answer for question number 16. In which does thermal conductor not conduction, sorry, not occur? Thermal conduction not occur. Thermal conduction not happen in vacuum. Conductions can occur in solid, liquid, and gases. The transfer of heat. But thermal conduction basically it cannot take place in vacuum. Does not occur. So we will go with the option number D. Next question number 18. The metal surface of a kettle is hot. What happens to the cool air outside the kettle when it comes into contact with the hot kettle? Hot kettle. Okay, hot kettle. Suppose this hot kettle. It is very hot. The body is very hot. The air surrounding this hot kettle, what happens? It gets heated, and the surrounding area, when it gets heated, it expands, its density decreases, and once its density decreases, it starts moving upward. It starts floating upward on the cold air and molecules of air. So now here, as per the four options, the density of air decreases, yes, and the air falls, no. It should move upward. Half portion is correct, but this portion is incorrect. And in B, the density of the air decreases. Yes, it decreases and the air rises. On the answer, correct answer. The density of the air cannot increase. The density of the air increases and air rises. Yes, Pari. Okay, just wait a minute. Just wait. So, question number 18, the correct answer is children, C. Question number 19, some hot water is sealed in a metal can, and the can is placed in a vacuum in outer space. In outer space, in vacuum, hot water slowly cool down. Then how does the thermal energy escape into the space? Hot water is sealed in a metal can, and then the can is taken to the space in vacuum. But the hot water slowly cools down. Water is cooling down, losing energy. How does the thermal energy escape into the space? What is the right answer here? We have a metal can, body get heated due to the conduction, and energy is losing. They said the bottles water cooled down slowly, so it means the heat is also going out. Conduction, through conduction, the some of the heat is conducted by the metal, and then that heat is taken out from the bottle into vacuum also as the temperature is falling. So vacuum radiation process take place. So what we will say here, the conduction and then the radiation process. First the conduction is there, and then radiation. Question number 20, when water waves pass through a gap, they diffract. The diagram shows wavefront approaching a narrow gap. In which diagram will the diffraction be least, minimum? Basically diffraction maximum or minimum depends upon the what? What factor? It depends upon the gap of width, length of width. And so let me tell you some rules. If the gap is large, let me write it. If gap is large, diffraction will be diffraction will be diffraction be minimum. So gap is large, I can find in option C and D. Here in A and B, the diffraction will be A and B diffraction will be maximum. We have to find for the least diffraction. So gap is large, diffraction will be minimum. But there is another rule. It's not about the gap always, but you have to compare gap width with the a wave or wavefront falling on the gap. If wavelength of the wave or wavefront is less than equal to width or gap, if lambda is equal to or less than equal to the width of the gap, then still the diffraction is maximum. That is a condition is noted down, diffraction maximum. But apart from that, gap is there, width is there, but if the wavelength, just wait a minute. I need to do some correction here. This is not the correct result, children. If lambda, let me erase this part first, children, so that you don't get confused. Uh, what I have, what I'm trying to say, that if lambda is equal to the gap width of the barrier, then diffraction is maximum. Or this is equal or nearly equal, basically. But in option C, that the wavelength lambda is lesser than lesser than lesser than this width or thickness or gap length. Okay, so then the diffraction will be minimum. Light or ray will diffract, but the diffraction will be minimum. You know, minimum means how to make the pattern like this much. In all the cases that the diffraction will be, light will bend more and more, and similarly here also. Like, so the answer for this question, right answer is option C. Let us do one more question, children. An object is placed 30 centimeter in front of a plane mirror. Which statement describes the image of the object? Image of the object. Object is placed where? 30 centimeter in front of a plane mirror. Let me draw a diagram. Suppose this is our plane mirror. Object is here. And then we know the image will form at the back side. This is the object, this is the image. And as per the question, they said uh, 30 centimeter in front of a mirror, this distance is 30 centimeter. 30 centimeter. And the object and image distance will be now 30 plus 30 because the image will form exactly at the same distance behind the mirror as the object is from the mirror. So what is the total length? This will be 30 plus 30, 60 centimeter. And in a plane mirror, image will form at of the same size and 60 centimeter from the object. So question number 21, right answer is B. Question number 22. A small object O is placed near a converging lens. The lens forms an image I. Which statement is correct? Which statement is correct, children? Read all options carefully and then we will identify. First, you can see from the object that how this is diverging, reflection from the lens. But if it is produced back, then they are appeared to be converged at this point I. So this is the virtual image. So this is the virtual image is formed here. And so if virtual, this portion is wrong. Virtual image is always erect and it is not diminished also. The image I is diminished, they said, very smaller than the size of the object. But look at the option D. The object O is closer to the lens than its principal focus. Where is the principal focus? Actually, this point is the principal focus. This I is the principal focus point, where the ray of light, after passing through the lens, they converge. That is the principal focus. And so we will go with the option D. Question number 23. An eclipse of the sun happens when the moon comes between the earth and the sun. Which statement is correct? Here, children, that this question is based on the electromagnetic spectrum, and I will go the direct with the answer that infrared radiation, ultraviolet radiation, visible light from the sun, all disappear at the same moment, at the same time. It's not about infrared radiations will be there, UV will be there. The sun, moon, and earth, when the eclipse take place, so at that time, this will happen. Question number 24. 24 is important, children. A bot is there sending a signal to the shallow fish here, and the sound travels through the water, and then it is reflected. Echo is heard after 1.2 seconds. Water speed of sound in water is this. How far below the bottom of the bot is the shoal of fish? Means you have to find this much distance. Suppose this distance is x. But if you see that in the question, the sound reaches the boat, sorry, the sound is produced from the signal at the boat, collide with the shoal of fish and return back. So in this case, the sound traveled a total distance of x plus x, that is equal to 2x. So total path length or the total distance covered is equal to how much? X plus x, that is equal to x. So the velocity value you can calculate by 1. Velocity equation is now distance divided by time. So velocity is given 1500, distance is 2x, and time taken by the sound is 1.2 seconds. So here you can calculate, children. 1500 multiplied by 0.2 divided by that is equal to x. So one side length or the depth of or the position of the shoal of fish from the boat. So decimal you can remove, 10 will be here, 10. And now 75 multiplied by 12. You can do the calculation. How much is this? 12 5 is 60, 0 or 9900 meter. I can find option number B. There is one more question I want to discuss with you, children. And the 25th question, question number 25 here. What is the approximate value of the speed of sound in air at normal temperature? This is again a normal simple question. Speed of sound is 340 meters per second. Why is soft iron used for the core of an electromagnet? Core of an electromagnet, soft iron is used. First, you have to remember. Electromagnets are temporary magnet, a powerful magnet but a temporary magnet. Now, as you look at the four options, soft iron easily becomes a permanent magnet. No. Electromagnet is a temporary magnet. Soft iron is a good electrical conductor. This is not about conductivity. Soft iron is a good electrical conductor. But we want to make an electromagnet. Soft iron is a poor thermal conductor. Wrong answer. Soft iron loses its magnetism whenever the current in the coil is switched off. We are looking for the, we want to make an electromagnet and soft iron used because it loses its magnetism as soon as the current is switched off. Immediately it gets demagnetized. Due to that, we prefer soft iron in making the core of electromagnet. In question number 27, a diagram shows two thin uh, uncharged strips of plastic. Diagram 2 shows the same strips after they have been rubbed with a dry cloth. Okay. Which row describes the charge on the strips after rubbing? After rubbing, children. After rubbing, you can see in the diagram, both the this position of the strip, they are moving away from each other. It means they are repelling each other. And repelling each other is only possible if they have the same charge, whether it is a positive or negative, doesn't matter. But I can see from the diagram they are moving apart, so there is a repulsive force between them, and so repulsion is there. I can see the repulsion here, I can see the repulsion here, and the repulsion is possible if they have the same charge. same charge is here, so that's why the right answer is B, not B. Question number 28, children. A cell has an electromotive force, EMF 1.5 volt, 1.5 volt here, children. You have to generally remember. This is a statement. And for the statement, children, that you have to memorize, a 1.5 means 1.5 joule of energy when driving 1 coulomb of charge around a complete circuit. That is called the 1.5 volt, 1.5 volt, 2.5 volt, whatever the value. It is the energy driving a charge of 1 coulomb per unit charge. That is called EMF of a cell. So the question number 20 answer is B. 29. Which two changes to a metal wire both increase resistance? We want to increase the resistance, children. And to increase the resistance, basically, we have one equation R proportional to length and area. I want to increase the resistance. Resistance increase by increasing the length and by decreasing the area. And there is one factor in case of a conductor, R is also proportional to temperature. If I increase the temperature, I need to say all these options. And now, in option A, decreasing its length. No, if I decrease the length, resistance will decrease. This factor is wrong. Option is wrong. Increasing the length, this part is correct. Decreasing the temperature, that is wrong, because if I decrease the temperature, resistance of the conductor also decreases. In option C, decreasing its thickness. If I decrease the thickness, yes, R and A are inverse proportional. Decreasing the thickness will increase the resistance, okay, and increasing the temperature. I found the right answer here at the C. But let us see the option D also. In D, increasing its thickness and decreasing the temperature, again, it is a wrong answer. So better you remember this equation. And in question number 30, diagram shows a circuit containing a DC power supply, a motor, and a variable resistor. Three emitters X, Y, and Z are there. And the reading on X is 4 ampere. Which statement is correct? See at the four options available. The reading on Y and Z are both less than 4 ampere. This variable resistor, motor are in series combination, and we know in series the same current flow. The current passing through the X is 4 ampere, and the same current should appear here. 4 ampere should be here at Z. So the reading on Y and Z are both equal to 4. Yes, this is the right answer. But let's say YC is wrong. Reading on Y and Z are both greater. It cannot increase. Okay. The reading on Z is 0. That is also wrong. So B is the right answer. So children, I have done this 30 questions here. The remaining 10 questions I can continue in our next video. This already is a very long video. Thank you.